right, this is the semester 2 final review, and what you need to do is copy down the problems on each screen and then work them out with me. So what I would suggest is pausing when I go to a new screen, copy the problems, and then watch me work them out. And after that, pause your video again, and then you work them out just to make sure that you're able to do that. So starting out in semester 2, we were in the chapter 6, and we were writing numbers, switching the forms from exponential form to radical form. So in the first problem, it says write in exponential form. Well, the exponent on the 7 is a 1. So exponential form would be 7 to the 1/3. And remember, this little number here is called the index of the radical, and that goes in the denominator. The next problem says write in radical form. So the index is 7, the denominator, and it would be to the 4th power. The next problem says to simplify. Now, hopefully you have your root sheet with you, or you can look at this and remember. So if we have the cube root of 8, you can do this a couple ways. Okay, the cube root of 8 would be 2. And then you square it, so that would give you 4. The next one, to simplify in this form, we can't simplify. However, if we write it in root form, you might hear the tractor in the background. I'm at school right now, and they're starting the demolishing of the old buildings, so it's very exciting. All right, next one is the 5th root then of negative 32. Well, 2 to the 5th power is 32. Negative 2 to the 5th power is a negative 32. And the 5th root of negative 32 is a negative 2, and then you cube it. So 2 times 2 times 2 is 8, and that will be a negative 8. All right, and remember with radicals that one of the main rules is you cannot leave a radical in the denominator. So we rationalize the denominator, and the way we do that is we take the number in the denominator, that root, and multiply by that number over itself. So it's equal to multiplying by 1. So that gives us in the numerator 2 root 5 over the square root of 25, which is 2 root 5 over 5. All right, rules of exponents. So when you are dividing exponents, numbers with exponents, you subtract the exponents, remember. So that would be 4 to the 2/3 minus 1/3, which is 4 to the 1/3 power. All right, and here in the next problem, you have another radical in the denominator, but the radical is part of an expression. So when that happens, we have to multiply by the conjugate, which means you have the same numbers, but different signs. Okay, so in the numerator, you have 1 times the square root of 3 minus 5. In the denominator, we need to FOIL. We have a binomial times a binomial. So the square root of 3 times the square root of 3 is the square root of 9. The square root of 3 times negative 5 is negative 5 root 3. And that would be a positive 5 root 3. And then the last number times the last number is a negative 25. So these cancel. And you have the square root of 9, which is actually a 3. So in the numerator, you have root 3 minus 5. In the denominator, you have 3 minus 25, which is a negative 22. And that's your answer. All right, the next slide, we have to simplify. So again, we're looking at radicals. And remember, with radicals, we can't have any perfect square factors underneath the radical. So you look at your square list, and 9 is a perfect square. 9 times 7 is 63. And the square root of 9 is 3. So that equals 3 root 7. Oops, I wrote that wrong. So that would be 3 root 7. All right, and then here you have to look at and say, okay, what goes into 28 that is a perfect square? Well, 4 does. So you have 2 here, and then the square root of 4 is another 2. and you have 7 right here, still underneath the radical. So that's 3 root 7 plus 4 root 7 minus 5 root 7. And now they all are root 7, so we add the coefficients in front. So 3 plus 4 is 7. 7 minus 5 is 2. So that would be 2 root 7 for my final answer. All right, in the next one, we're looking for perfect cubes here, factors that are perfect cubes. So 8 times 2 is 16, and 8 is a perfect cube. All right, so the cubed root of 8 is a 2. 2 stays in there. The cubed root of x cubed is x, and you have 1x inside, so that's your answer. All right, next we're going to solve for x. So this has a square root in it, and the x is inside the square root, so we need to get the square root term by itself. So the first thing we're going to do is divide both sides by 3. So we have the square root of x plus 2 equals 4. Now, how do you cancel a square root? Well, you square it. It's the opposite. So we're going to square both sides. So you end up with x plus 2 equals 16. So x equals 14. All right, next problem, x to the 3/4. So let's first write this as a radical. So that would be the 4th root of x cubed minus 9 equals 18. Now the x is in the radical, so we want to isolate that term. So we're going to add 9 to both sides. First thing we want to do is multiply or raise both sides to the 4th power, because the 4th root and the 4th power are inverse operations. So we have x cubed, and this is going to be a big number, 27 to the 4th equals 531,441. And now we're going to take the cubed root of both sides. So 3 cubed root 531,441 is 81. And that's your answer. All right, now let's talk about function notation. So we're given an f of x function and a g of x function. So it's first, it says find f of x plus g of x. Well, what does f of x equal? It equals x squared plus 3x minus 28. And then what does g of x equal? X plus 7. So you just substitute what they equal. Now we will simplify. So you have x squared, and then 3x and x is 4x. And then negative 28 plus 7 is a negative 21. And that's it for that one. Now we're going to do function composition. Now remember with this, what we do is we start on the inside. You need to find f of 2, which means in the f function, you want to substitute in a 2 for the x. So f of 2 would equal 2 squared plus 3 times 2 minus 28. So that would be 4 plus 6 minus 28. And that's a negative 18. So g of negative 18. And then what we're going to do is substitute negative 18 in for x. So we would have negative 18 plus 7 is a negative 11. So in the g function, g of negative 18. So you have a negative 18 right here, plus 7, and that gives you negative 11. All All right, now we're going to solve for x, but if you'll notice, the x is in the exponent position. So in order to do that, we need to put it in log form. So what we're going to do is write, remember how we do this? Log base 3 of 18 is equal to x. And if you have a number here and a number here, we can use the change of base formula. So we type in our calculator log 18 divided by log 3, and you'll find out what x is. So let me type that in. Log 18 parenthesis divided by log 3, and we end up with 2.6. All right, let's do another one like that. First thing you want to do is isolate the term that has the x in. So let's divide by 3. So you have 7 to the 2x equals 5. And at this point, we'll put it in log form. So log base 7 of 5 equals 2x. So here we use the change of base formula, log of 5, parenthesis, divided by log of 7, and that gives you 0.83 equals 2x. And now to get x by itself, we divide both sides by 2. So x equals 0.41. All right, the next one, notice we have variables on both sides. And if we look here, we have 8 and 16, which they have common bases of 2. So 2 cubed is equal to 8, but this is 1 over 8, so that would be 2 to the negative 3. Okay, and then you also have 3x up there. Now 16 is 2 to the 4th, and so then you have x minus 3 still up there. Okay, so 2 to the negative 3rd would be the same as 1 over 2 to the positive 3rd, which is 1/8. Okay, so 2 to the negative 3rd is the same as 1/8. So you end up with 2 to the negative 9x equals 2 to the 4x minus 12. We have now the same basis. So what we're going to do is set the exponents equal and solve. All right, so now we will solve for x. So that gives us a negative 13x equals a negative 12. Divide both sides by negative 13. So x would be 12 over 13. And the last problem on this page, the x is inside of here. So, and we can't solve it this way, so we're going to put it in exponential form. So 2 to the 5th power equals 3x minus 5. 2 to the 5th is 32. And then we solve. And then lastly divide. So x equals 37 divided by 3 is 12.3 approximately. All right, so the next one says your 3-year investment of $20,000 received 5.2% interest, compounded semi-annually. What is your total return? So we have the compound interest formula, and so the amount that we're going to get back is equal to the principal, which is $20,000, 1 plus the rate. Now remember, changes to a rate, we move the decimal over 2 places to the left. And then n is the number of times per year you compound it. Semi-annually means twice. And then nt, n is 2, and then time, 3 years you leave it in there for. Now right away, remember I said change that to a 6. So let's put this in our calculator. And I end up with 23,329.97. So $23,329.97 at the end of 3 years. All right, chapter 8, rational equations. So first of all, we want to simplify whenever we can, and you'll notice here you have an expression on the top. There's a plus there. Whenever you see that, throw parentheses around there to remind you that you can't just go in and cancel one thing. We can factor the numerator though. You could take out a 4 and a d from each term, which gives me a d plus 2. Okay? And now, remember, we can cancel factors. So 4 and d plus 2, those are the factors in the top. And 2 and d are the factors in the denominator. So 4 and 2 cancel. Okay, the d's here will cancel. So we end up with 2 times d plus 2 for an answer, or you could write that as 2d plus 4. All right, the next one, we have division. So we have, I'm going to factor this first. X and x, 4 times 2 is 8, minus 4 plus 2 gives you the negative 2. So you have x minus 4 and x plus 2 over x plus 3. And then instead of division, you have times. Okay, so then, whenever there's a plus or a minus, we're going to put parentheses around. Remember, that's an expression. The x plus 3's cancel. The x minus 4's cancel. We're left with x plus 2 for your answer. Next one, we're adding. Now, if you recall with fractions, you need a common denominator. And the easiest way to do that is to find the factors of the denominator. And first, we're going to factor out this term. So this has an x times x plus 3. This one only has x plus 3. So you need to multiply by x over x. So now notice the denominators are the same. And what we'll do is add across the top then. So you have x minus 3 plus 7x. And we can combine like terms. That would be 8x minus 3 over x times x plus 3. And that's your final answer. All right, probability. You're choosing an outfit to wear for a job interview. You're picking between 6 pairs of pants, 4 shirts, and 2 shoes. How many different outfit options are there? Well, this is actually a counting principle problem to figure out how many possibilities that we have. So we have 6 pairs of pants, 4 shirts, and 2 shoes. So the counting principle says we multiply those together. 6 times 4 is 24 times 2. That means you would have 48 possible outfits that you could wear. All right, next problem. 10 people enter a race. If there are no ties, how many ways can they finish first, second, and third? So 10 people are entering the race. And you want to figure out how many ways they can finish first, second, and third. So the big question, if you're to ask yourself, does order matter in this problem? Well, yes, because we're looking at specific positions, first, second, third. So that is a permutation. Or you could do it this way. There are 10 options here, 9 options for the next position, and then 8 people could come in third. So that would be 720. And it looks like that is all that I have for you for this semester. So it's been a crazy journey for us, guys. So I hope that as we've reviewed this, this is kind of coming back to you and you've learned some things to carry on next year to Algebra 2 or wherever it is that you're going next year. So what I need you to do is take a picture of this review and send it to me and return your materials, your book. Next week, you'll be hearing from the office on that. And lastly, have a wonderful, safe summer. Thanks, everybody. Bye-bye.